Hey everyone, it's Mr. Phillips here, making it clear, making it plain, opening up the heavens for my teachings like spring rain. And today, we're gonna balance those simple synthesis reactions. Let's go. All right, let's get down to it, balancing simple synthesis reactions. So the objective here is that we're going to apply the law of conservation of mass to the rearrangement of atoms in a chemical reaction in order to balance a chemical equation, okay? So we want to make sure that the reactants and the products are the same on each side, all right? And the key here is that relationships between quantities are equivalent. So the quantities that we're working with are the reactants and the products, and they have to be equivalent. If they're not equivalent, then it's not a balanced chemical equation. Here are some tips, all right? These tips might look a little intimidating at the start, but since we're working on simple synthesis reactions, these tips may actually be a little bit deceiving. So once you get in, see some of the examples, then you'll understand that some of these tips are actually for more difficult problems, okay? So first, we're going to identify the reactants and products. We're gonna count our atoms and our ions if we need to count ions, okay? Then we're gonna find out which element to balance last first. That's like the number one rule right there, honestly. The biggest thing is finding out which one do you balance last first. Then you find out which one you balance first, okay? So the element that you balance last is usually a solo element like metals, okay? And then the element that you balance first is usually found in multiple places, and it also may not be as lonely as like a metal. And when I say lonely, meaning it outnumbers the metal. And so we're gonna adjust our coefficients in the chemical equation one atom at a time. Make sure you do that one atom at a time, okay? And then we have to watch to see if other atoms change. And if they do, then we need to continue adjusting. And we solve the problem when we finally get to that last atom because we identify which atom we balance last at the very beginning. As soon as we balance it, that's when we know we're done. And you'll see that the number of atoms on the left side and the right side are equal to one another. Okay, here we go. So we have the reaction of potassium with chlorine, and we're going to, first of all, count the atoms on each side of the equation, the reactants and the products. So if we start with the reactants, we have 1 potassium and 2 chlorine. Then we have, on the product side, 1 potassium and 1 chlorine. So they're not balanced. The number of chlorines outnumbers the number of the chlorines. So the number of chlorines on the right side, the reactants, outnumber the ones on the product side, okay? And so which one are we gonna balance last? We're gonna balance the loneliest element last, that metal, which is potassium. And so then the only other element that we're gonna balance first is chlorine. So let's keep it moving. We're gonna balance the chlorine first. So I'm going to multiply the product side by a number to make it equal to 2. So what number can I multiply 1 by to make it equal to 2? I'm gonna multiply it by 2, okay? And I'm going to put a 2 in the blank in front of KCl on the product side, which is the coefficient. 2 is a coefficient. But the thing is, potassium and chlorine are attached to each other. So because I'm multiplying the chlorine by 2, I also have to multiply everything that's attached to it by 2. So that includes the potassium, okay? And so I have 2 KCl's. So I balance the chlorines. I have a 2 on the left and a 2 on the right, a 2 in the reactants, a 2 in the products. But now the potassiums are not balanced. So guess what? We're about to balance potassium last. So that means we're almost done with this problem. So if I have 1 potassium atom and I want to multiply it by a number to make it equal to 2, what number would that be? It's going to be 2. So then I put a 2 only in front of the potassium, in front of the K. At the end of the day, this balanced equation is 2, 1, 2. 2 potassiums reacts with 1 chlorine molecule to produce 2 KCl's, all right, potassium chlorides. And so as you can see, I tried to give you some visuals so you can see that there are 2 potassiums here, 2 over here, and then 2 chlorines on the left side and 2 chlorines on the right. They're just arranged differently. Okay, so we're using the law of conservation of mass to support the rearrangement of atoms, okay, so that we can balance it. All right, let's try another example. This time we're going to look at copper reacting with sulfur, S8 this time. That's a little bit special right there. And it's going to react to create copper sulfide, okay, copper 2 sulfide. So let's count our atoms first. On the reactant side, we have 1 copper and 8 sulfurs, okay? And this is how they are arranged, okay? And then if we go to our product side, we have 1 and 1, okay? So clearly we have 1 copper on each side, and then we have 8 sulfurs on our reactant side, and then 1 sulfur on the product side. So it's not balanced. So which element are we going to balance last? I hope you are thinking about copper, okay? So copper is going to be balanced last, which means as soon as we balance it, it's going to be finished. Now it looks balanced now, but I guarantee you when we're done, we're going to need to rebalance it. So then the only other element we have left to balance first is going to be sulfur, okay, sulfur. So let's begin that process. I have 8 sulfurs on the left side, which is the reactant side, and I have 1 on the product side. What number do I need to multiply the product side by to get 8? Well, I'm going to multiply by 8, okay? And because this copper is attached to the sulfur as well, that means everything has to be multiplied by 8. So I put an 8 in the blank, but I need to also multiply copper by 8, like so. Okay, so notice, whoa, see that imagery right there? You see that imagery? I had to multiply everything by 8. So now I have 8 coppers and 8 sulfurs on the product side. And so things look good with sulfur, but now copper is looking a little crazy. Copper is outnumbered on the product side compared to the reactant side. So what do I need to multiply by on the reactant side, the left-hand side of the equation, to get 1 equal to 8? Well, I'm also going to multiply that by 8 as well. All right. So see that imagery? We need 7 more copper atoms, but we multiply by 8 to get the 8. Okay. And so now that I've balanced the copper, I'm actually done with the problem. That is how I know that I'm done. When I have correctly balanced the last element, okay, that I listed in this table, which is copper. So just to recap, the most important thing about applying the law of conservation of mass to the rearrangement of atoms to balance chemical equations, you have to know which one you're going to balance last, and you have to know which one you're going to balance first. This rule is consistent no matter how more complex these problems get, okay? So these are the simple synthesis reactions, but I guarantee you, if you can master just picking the first and the last elements that you got to balance, then balancing chemical equations is going to get easier and easier for you with more practice. Thank you for tuning in to You'll Be Blessed Education. I truly hope that you were edified by this teaching. And if you're looking forward to more content, then just simply subscribe to this channel, like this video, share this video. Make sure you click that little bell so that you get some notifications of the next uploads. Again, this is You'll Be Blessed. Thank you for tuning in. Have a great day.